So what is standard deviation? This is another measure for dispersion, right? And it was given in 1893 by Carl Pearson. Okay, this is the most important kind of dispersion method because it is widely used and it is most accurate. It is also known as root mean square deviation. Why? Because if you see at its formula is the root of mean of square deviations. So square deviations means this is your given data x, you are subtracting mean from it, that is the deviation, right? Deviation from the mean. Deviation means that is either up or either down. So you are squaring that quantity, so that means that is square deviation. And then you are taking its mean. Taking its mean means you are adding up all such quantities and then you are dividing by n. So that means taking your mean and then you are taking the square root of that whole quantity. So this implies that it is also known as root mean square deviation. So it is denoted by this symbol sigma and the formula is summation square root of x minus x bar whole square divided by n. Moreover, this is the absolute measure of dispersion. Why? Because it has the same units as that of the given data. The units are same. Next, we will define what is the coefficient of standard deviation. The coefficient of standard deviation is defined when you divide this standard deviation by the corresponding mean. This is now a relative measure of dispersion. Why? Because standard deviation has the units of the given data, and x bar that is the mean and that also has the units of given data. So that means this whole quantity, this ratio is dimensionless. So that is the coefficient of standard deviation. So now we define what is the basic difference between this mean deviation and standard deviation. In mean deviation, what we do? We just calculate this quantity modulus of x, which is the given data, minus either x bar if you are taking the deviation from mean, or you do x minus m, where m is the median if you are taking the deviation from median, right? And in standard, so here we take this modulus sign. So that means we are ignoring this sign of plus and minus. So we are ignoring this sign completely. But whereas in standard deviation, we are not ignoring the signs because we are not doing the modulus, but we are doing the square of that particular quantity. So the signs here in this case are not ignored at all. Moreover, calculation of mean deviation is either from median or from mean or from mode, whereas the calculation of standard deviation is always taken from mean, because here the sum of squares of deviations is taken from mean. Whenever taken from mean is the minimum. So next, let us see how can we calculate the standard deviation whenever we have either the individual series or we have the discrete or the continuous series. So these two things we shall see. Following are some of the formulas. So first formula for individual series is this actual mean method. So here this formula is utilized. In the assumed mean method, we calculate d instead of x. And what is this d? D is x minus a. And this a is the assumed mean, which is not the actual mean, but we assume it by ourselves. Okay, this could be the mean. So we calculate the deviations from that mean d by subtracting this assumed mean a from all these given data quantities. So we subtract a from the given data x. So once you have this d, you can compute what is d square and then add up the quantities. And once you compute d, you could add up those quantities and then square it. So this is the second formula. And the third formula is the major one, which is majorly used. That is the step deviation method. Here we calculate d dash instead of d. So what we do, we assume a as sum of the assumed mean. This would be more clear from the examples. Okay, so A is the assumed mean. So first what we do, we calculate small d, that is given data minus this assumed mean, and then we calculate d dash, that is the given data minus assumed mean divided by the interval length, that is I. So this is the case here. N is the total frequency, A is the assumed mean, I is the interval length. And the formula here is the same, but now it is d dash instead of t. And for the discrete or the continuous series, we have this three formulas. The formulas are same, but the calculation method would be somewhat different. So first method is actual mean method. This method is rarely used in practice. The second method is assumed mean method, and the third one is step deviation method. This is the one which is mostly used in most of the calculations. So let us see some examples. The first example is that of individual series. That means raw data is given to us. Okay. So this is the given data, and we are asked to calculate the standard deviation for the following data. Now in order to calculate standard deviation, the first task is to calculate what is the mean. So you just wrote your data x into this column. Next you calculate the mean out of this quantity. So what you do in order to calculate mean, x bar, mean is calculated by taking the summation of all the data points and then dividing it by the total frequencies in this case. So this is the given data. So you add up all this data. You have this quantity 200, and how many observations are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we have total 10 observations. So therefore your mean would be 200 divided by 10, so that is 20. So this is the mean. Next we have to calculate standard deviation. So for that we will use this particular formula, summation of x minus x bar whole square divided by n, then its square root. So firstly we will calculate what is this quantity, x minus x bar. So this is your given data. What is your x bar? You have just calculated this to be 20. So this would be x minus 20. So that means 16 minus 20 is minus 4. 20 minus 20 is 0. 18 minus 20 is minus 2. 19 minus 20 is minus 1, and so on. You keep on doing this up till the last value, and then whatever is this quantity, you just square that quantity. So minus 4 square is 16, 0 square is 0, minus 2 square is 4, minus 1 square is 1, 0 square is 0, 8 square is 64, minus 3 square is 9, and so on. Now next step is add up all these quantities. So when you add up all these quantities, you have this to be 98. So when you substitute this 98 here in this place, so you have square root of 98 divided by n. N is 10. So your final answer is 3.13. So this is how you calculate standard deviation for the discrete series. Now we have another discrete series. Okay. This is also discrete series, but here we will use another formula. The formula is, we will calculate the standard deviation using this particular formula. So what is this standard deviation formula? It says you will first calculate this small d, take its square, sum up all these quantities, divide by n. So you get this first term. For the second term, take the sum of all the d's, divide by capital N, and then square those quantities. So this is what you have to do. So this is for that you just firstly have to calculate the mean for the given quantity. So how do you calculate mean? So there are two options. First option is you calculate what is the actual mean. Another option is you assume that this is the mean. So looking at the data, your data starts with 7, 10, 12, 13, 15 and keeps on increasing up to 35. So if you look at this data, if I assume this to be my mean, I assume by myself that this is my mean. So what would be the deviation in this particular case? So what we have done, we have taken some middle value out of this and we have assumed that the mean would be nearly equal to this one. So we assumed A to be 20 and this is the assumed mean. This is the assumed mean. So next task is you calculate what is x minus a. So x minus a is 20. So 7 minus a would be 7 minus 20. So that is minus 30. Next 10 minus 20 would be minus 10. Then 12 minus 20 would be minus 8 and so on. So you complete up this column like this and then you square up all these quantities. So once you square minus 13 you have 169, once you square minus 10 you have 100, once you square minus 8 you have 64, minus 7, 49 and so on. So you add up finally all these columns. So you would have this as the summation x minus a bar. What is this a bar? Or you write this to be a. So this is the deviation. This is the sum of deviation from the assumed mean. This is the sum of deviations from the assumed mean. So now you have this deviations from this assumed mean. So what is this? This is d square. What is this quantity? This is d. Because what is d? D is, your d was x minus a. So you just substitute this value d here instead of this summation d. So you have minus 10 here and you just substitute 778 in place of summation d square. So you have 778 here divided by n, taking the square, solving. So you have the standard deviation as 8.76. Next, for the discrete series using the third formula, what do you have? That means you have the x values here, the frequencies here. So how can you calculate the standard deviation from this one? So for that we shall be using this formula, summation f multiplied by the deviations. So basically what is this formula? This formula is summation square root of sigma is equal to the standard deviation, that is equal to square root of summation frequency multiplied by deviation square divided by n minus summation frequency multiplied by deviation divided by n whole square. What is this quantity? This is actually the mean for this discrete series. So what we are doing here is we are calculating d first. D is x minus a and we are then performing the calculations. So you just see this is the given data, this is the values of x, this is the given frequency. So first we are doing it is we are calculating this deviations from the assumed mean. So for that you can assume any value of a. Here in this particular case, what value I have assumed to be a? I have assumed a to be quantity 4. What value I have assumed? I can assume this to be 6. So this is a and this is my assumed mean. So if this is the assumed mean, so that means what I am doing is I am subtracting all the data values, I am subtracting 6 from all the data values. So that means 3 minus 6, that is minus 3, 4 minus 6, that is minus 2, 5 minus 6, that is minus 1, 6 minus 6, that is 0, 7 minus 6, that is 1, 8 minus 6, that is 2, then 9 minus 6, that is 3. Okay, this is our d. And what do we require here? In this case, because here frequencies are also given, so we will multiply the corresponding values of d with f. So here what we are having? We are having f into d. So we are just multiplying this d with f. So 7 into minus 3, that is minus 21, then 8 into minus 2, that is minus 16, 10 into minus 1, that is minus 10, 12 into 0, that is 0, 4 into 1 is 4, 3 into 2 is 6, and then 2 into 3 is again 6. So this is the column and then you add up all these. So you add all these, so you finally would have summation f x minus a, that is equal to minus 31. This is one term that is required for calculation. Another term that is required here is f into d square. What is d square? F is this column, d square is square of this column. So basically what you are doing, you are calculating for this particular quantity, what you are doing, you are writing f d square. So what is f? F is the 7. What is d? D is minus 3. So minus 3 whole square. So it is 7 into 9, that is 63. So this is the first quantity. For the second quantity, it is 8 into minus 2 square. So that would be 8 into 4. So that is 32. And so on. So you complete this column in this way, add up all the quantities. So you would have 139 as the value of summation f d square, this quantity, and the value of summation f d. What is this? This is minus 31. So you just substitute all these values here. So you would have the value of this as 139, the value of summation f d as minus 31. Total n values is sum of all these frequencies, so that is 46. So when you calculate this one, so your final answer would be 1.602. That is the standard deviation. Now here we see the next example. In this example, what we are doing, we have to calculate the mean and the standard deviation for the following data. Here age is given to you and the number of person is given to you. So now read the question carefully. The age under 10, 15 people are there whose ages are less than 10. There are 20 people whose ages are, there are 32 people whose ages are less than 20. So now this 32 people will definitely include this 15 people. Why? Because the age, these 15 people would have age less than 10, which is also less than 20. So that means here this is not the given frequency, this is the cumulative frequency that is given to you and not the direct frequency. So how do you calculate this frequency from the cumulative frequency? That is simple. We just have to subtract instead of adding. So now we just create a class interval for this. So we say from 10 to 20 we'll calculate how many people are there. Then from 20 to 30 we'll calculate how many people are there. Then so on. So we make this class intervals from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Here we are given this quantity. So here they have given to you that the people under age 10, so that means 0 to 10 age, this interval has people 15 and they are given age under 20, that means 0 to 20 the number of people are 32. Here it is given under age 30, so that means 0 to 30 it is given 51 and so on, 0 to 40, 0 to 50 and 0 to 60. So that means you have to convert these kind of intervals into these intervals, 0 to 10, 10 to 20, 10, 20 to 30, 30 to 40, 40 to 50, 50 to 60. How? You will first calculate the frequencies. So now from 0 to 10 it is clear the value of frequency is 15. That would come as such. The next term between 10 to 20 would come up by subtracting this 15 from 32. So basically what is this quantity? This is cumulative frequency 32 minus the previous frequency, that is 15. So the answer is 17. The next term would be this quantity 51 minus this 32. So this would be 52 minus 51 minus 32. So this would be 19. And then you would have 78 minus 51. So this is 78 minus 51. So that is 27. Then you have this 97 minus 78. So then you have 97 minus 78. And then you have 109 minus 97. So that is 12. So when you add up all this, you see this is same as this last quantity. So that is the meaning. This is cumulative frequency sum is equivalent to the sum of total frequency. So this column you have to make by yourself and just take care that you do not commit mistake with this question. Next is, we wanted to calculate this mean and standard deviation. For that, we'll calculate the middle values of this class interval. So middle value is the lower limit plus upper limit divided by 2. 0 plus 10 is divided by 2 is 5. 10 plus 20 by 2 is 15, and so on. Next, in order to calculate the mean, we can use the assumed mean method. So for that, what you have to do, you just assume that 35 is my mean. This you assume by yourself. So for that, for calculation of mean, the formula for assumed mean is this one: A plus summation f d dash divided by n into I. This is the step deviation method to calculate mean.
Excuse me, ma'am.
Yes.
Ma'am, about the...
So how do you calculate this d? D is calculated by x minus a. A is the assumed mean, this is the given data. So you subtract this this 5 from this assumed mean 35. So that would be minus 30. Then you subtract 35 from 15, that would be minus 20, and so on. Complete this column. Then you compute d dash. D dash is d divided by I. I is what? I is the interval length. Interval length is upper limit divided minus lower limit. So upper limit is 10, lower limit is 0. So I value is 10. You see 50 minus 40 is also 10. So this is constant for every class interval. So what we do, we compute d dash from here. D dash is d divided by I. So that is minus 30 by 10, that is minus 3, minus 2, minus 1, and so on. Next task is we compute f into d dash and then f d dash square. What is f? F is this quantity, this multiplied by this d dash. So we multiply this whole column with this whole column. So you would have 15 into minus 3 minus 45, 17 into minus 2 minus 34, 19 into minus 1 minus 19, and so on. Then you add up all these. So you have this quantity minus 55. And then you compute f into d dash square. D dash is this one, minus 3, minus 2, minus 1, 0, 1 and 2. Firstly, you will compute what is d dash square. So d dash square would be this quantity 9 and then 4, then 1, 0, 1 and 4. And then you multiply this with the corresponding frequency. So you have this column. Then you add up all these. So you would have 289 as the final answer. So using this step deviation method, the standard deviation would be using this formula. So you have the value of this quantity, that is minus 55 over here, and then you have the value of summation f d dash, that is the value of 289, and then you write up all these values, and this is the final answer.